Hi, welcome to MACSGATE. We are learning DBMS subject. Under DBMS subject, we are discussing transaction management chapter. In transaction management, in the last session, we have started what is a schedule and what are the types of schedule. And in today's session, we are going to discuss about serializability. What is serializability or what are serializable schedules? How to verify whether a given schedule is serializable or not. So that is what we are going to discuss in today's session. Let us start the session. Serializable schedules. A transaction schedule is serializable if it is equivalent to any one of the serial schedules. Maybe the given schedule is not a serial schedule, but it should be equivalent to one of the serial schedules. Suppose I have two transactions. I may have a serial schedule T1 followed by T2, or I may have a schedule T2 followed by T1. So this is one serial schedule and the second one is this one. If the given schedule is equal to any one of these two schedules, then we say it is a serializable schedule. Now the question is, what is meant by equivalence? We are saying the given schedule is equivalent. Now, what does it mean? So, when we say they are equivalent, that is what we need to discuss first. Types of equivalence. How to verify the equivalence? So, there are three ways to verify the equivalence, or we can say three types of equivalences between the schedules. The first one is result equivalent schedules. The second one is conflict equivalent schedules or conflict serializability. And the third one is view equivalent schedules or view serializability. So these are the three types of equivalence between schedules. Let us discuss each of these one by one. The first one, result equivalent schedules. What is meant by result equivalent schedules? Two schedules S1 and S2 are said to be equivalent schedules. So their intention is result equivalent schedules if they produce the same final database state. What is meant by it? Let me explain with an example. Suppose I have two transactions T1 and T2. Let us assume I have two bank accounts. So the transactions are between bank accounts. Let us assume we have two bank accounts. One is X, the second one is Y. The first transaction wants to transfer from X to Y some 100 rupees. The second transaction wants to add some 1000 rupees. So to the X account, it wants to deposit 1000 rupees. Now, before going to the further details, let us assume the initial balance of X is 5000. And similarly, the initial balance of Y, let us assume some 2000. So these are the initial balances. Okay. Now let me give one non-serial schedule. One non-serial schedule. What does it mean, sir? We can switch to transactions without completion of the started transaction. For example, what is generally T1, sir? In T1, the first thing is they need to read the value of X. Then they need to update the value which will subtract minus 100 because you want to transfer 100 rupees. Then you need to write back the updated value. Then we need to read the value of y. We need to add the 100 rupees to y. Then we need to write this value to the database. This is my T1, sir. Then what is T2? Just we need to add 1000 rupees to the account X. So for that, first I need to know what is the initial value of X. Then add the 1000, what we supposed to do. Then write back the value of X. So these are the two types of transactions. Now let me give an example of a non-serial schedule. In non-serial schedule, I can switch from one transaction to another transaction, even if I have not completed the started transaction. Okay. So let me give like this. First, okay, let me write like this. T1, T2. The first step I perform is I will read the value of X from T1. Okay. Then let us do the operation X equal to X minus 100. Then I write the value of X. Then I switch to transaction 2. I read the value of X. Then I read the value of 1000. Sorry, we will add the value of 1000. Then we will write it back. Then read the value of Y. What I need to do for Y, sir? We need to add 100 rupees. Then write it. Sir, this is an example of a non-serial schedule. Why? Because without completion of T1, we switch to T2. Is it clear, sir? Now, suppose I completed all the operations of T1. Okay. I'm not writing it all again, sir. So, 1, 2, 3, 4, 5, 6. Then I will do or I will start the operations of T2. This is one of the serial schedules, sir. Okay. First, let us consider this situation. Okay. Again, let me write the values of X to have more clarity. This is my X, this is my Y. This is 5000. This is 2000. If you do this schedule, assume this is my schedule 1. For schedule 1, first you are reading the value of X. What is the value of X, sir? 5000. Then you are subtracting 100. So it will be 4900. You are writing back that value to the X. So it will be 4900 in X. Then you are reading the value of X. Here what can have the value of X, sir? That is 4900. Then you are adding 1000. You will get 5900. So this you are going to write back. So here how much you get? 5900. Then you are reading the value of Y. What is the value of Y, sir? 2000. We are adding 100 rupees. 2100. That we need to write to here. So initially or before this schedule, what is the state of the database? The state of the database is X is having 5000, Y is having 2000. After this schedule, what is the state of these two variables, sir? The value of X is 5900 and the value of Y is 2100. That is the meaning of the database state. Now suppose if I follow these lines, so let me write again the same values. This is my X value 5000. This is my Y value 2000. Now if I do this serial schedule, first we read the value of X 5000. Update it. That will be 1 minute, sir. 4900. that you are writing back. So that will be 4900. Then you are reading the value of y, that is 2000. You are adding it, 2100. You are writing back. It will be 2100 rupees. Then again you are writing, sorry, you are reading the value of x, that is 4900. Then you are adding 1000. So it will be 5900. Then you are writing it back. So it will be 5900. So what is the state of the database if I follow the serial schedule, sir? The same. X is having the value 5900 and Y is having the value 2100. Hope you understood it. So these two schedules producing the same state of the database. So that's why these two will be said to be equivalent. Hope you understood it. So this non-serial schedule is equivalent to one of the serial schedules. Okay. So that's why we can say this is a serializable. Serializable means even if I do the transactions concurrently or simultaneously, the result will be equal to one of the serial schedules. Okay. So that is about result equivalent schedules. Now the main problem with result equivalent schedules is we need to know what are the initial values and what is the specific operation we are going to do on that particular object. That means I need to know how much I am adding, what is the initial value. So to verify this type of equivalence, I need to know the complete details of the operations. But without knowing the complete details of the operations also, we can verify whether two given schedules are equivalent or not. For that, we need to go for conflict serializability or view serializability. Hope you understood the first type of equivalence between the schedules. Result equivalent schedules. Conflict serializability, or what are conflict operations? Conflict operations. Sir, suppose I have two transactions T1, T2. If the first transaction is working on a data item X and if the second transaction is working on a data item Y, there is no problem at all because two people are working something like two different systems. So then there is no chance of conflict because one person should not disturb the other or one transaction should not influence the second one. So when both are working on two different data objects or data items, there is no conflict at all. This is the first possibility. Now the main problem is, let us assume the both the transactions working on same data item. If the operations of the transactions are working on different items, there is no conflict, sir. Okay. Something like I have a operation, I am writing x equal to x plus 100. In second one, I have a operation, let us assume some fourth operation, y equal to y plus 50. Then there is no conflict at all, sir, because both are working this one. So either I can do this operation first or I can do this operation first. There is no issue. Even I can do first fourth operation, then I can go for the first operation. But let us assume the both the transactions are working the same data item X. They are working on the same data item X. Then if both the transactions are reading, that means the operation of T1 is reading the value of X. The operation of T2 also reading the value of X. Then there is no issue at all because both are reading. So no one can influence others. So there is no conflict at all. But the problem is, suppose T1 is reading the value of X, T2 is writing the value of X. Then the problem comes. The question is, what T1 needs to read the value? Whether it needs to read the initial value or whether it needs to read the updated value. That we don't know. That depends on the transaction. If T1 needs to read the initial value of X, we need to form a schedule in which always it needs to read the initial value of X. Okay. So originally, let us suppose this is the sequence I need to follow. That means T1 needs to read the old value, then it needs to be updated. So I cannot change the sequence of this operation. That means first I cannot update and then I cannot read, because in this case what is happening, sir? T1 is reading the updated value, but that fellow need to work the previous value. So in this case I should not change the order of the transactions, but here we can change the order. There is no problem whether you do 1 first or 4 first. But when coming to here, whatever it's supposed, that I should not change. Similarly, suppose T1 wants to modify the value and T2 wants to read the value. With the same logic, there is a conflict. So these two people are having the conflict. And there is one more set of operations. Both people are working and both people are writing. So even this case also there will be a conflict, because you are writing the value of X. That means you are modifying the value of X. Suppose if a modification depends on the value of X, what is the value supposed to work? Old value or new value? So when you are having the second set of transactions, whatever the sequence they given, we cannot interchange or we cannot change. We cannot interchange the operations. Hope you understood it. So that is about the conflict operations. So when two operations are working on the same data item, there is a possibility of conflict. That is the first point. Suppose if both operations are working on different items, there is no concept of conflict. And even in such case also, if you observe this box, one of the operations is write operation. When one of the operations is write operation, surely they will be conflict operations. One of the operations is write operation. And of course, they must be on the same data item. Then only there is a conflict. Okay. Now we are ready to discuss what is conflict serializability. Conflict equivalent schedules. What is meant by conflict equivalence, or when can we say two schedules are conflict equivalent? Two schedules are said to be conflict equivalent if the conflict operations in both schedules are executed in the same order. So the conflict operations in both schedules are executed in the same order. Suppose I have schedule 1 and I have schedule 2. Okay. Let us assume I have 2 transactions, and let us assume I have 2 transactions here. Let us assume here I have some operation 5. Assume here I have some operation 7. That may be immediately or somewhere else, sir, no issue. But here also operation 5 should appear first. Maybe after so much time, you may have after operation 7. So the order, what is the order, sir? Operation 5 first. In this case, operation 5 first. Operation 7 next. Okay, you should not be like that. Operation 7 I executed first, then after some time I executed operation 5. Then these two will not be equivalent, but these two are equal. Okay, instead of equivalence, let me write equal. Hope you understood it. So when there are conflict operations so in both schedules the order should be same. Suppose there are no conflict operations, no problem at all, sir. Always there are conflict equivalents. Okay, let me give a small example. Suppose this is my schedule 1. Why to consider another example, sir? Let us consider the same example. X to Y, and let us suppose it is transferring 100 rupees. T2, it is adding 1000 rupees. Now here I don't know the initial values of X. No need also. Okay, let me write one schedule. Okay. First I read the value of X in first transaction. Then we update. How much you updated, that no mind. Then the third step, we read the value of X in second transaction. Then we write the value. Okay. Then we come back here. We read the value of Y. Then we write the value of Y. This is one of the non-serial schedules. Let me give one more schedule, which is a serial schedule. I read the value of X. I write the value of X. Then again I read the value of Y. I write the value of Y. Then the fifth one is I read the value of WX. I read the value of this one. Okay. Sir, now please listen to me. First of all, we need to identify what are the conflict operations. Conflict operations. Okay. Sir, please observe it. Here it is writing the value of X. Here you are reading the value of X. To have more understanding, let me write W1X or 2X. That means the first transaction is writing the value of X. The second transaction is reading the value of X. Now, in first schedule, who is first, sir? W1X first. R2X next. Am I right, sir? Sir, next in the sense that may be immediately or that may be after some time. I don't mind. The competition is only between these two operations. Who comes first? That's it. What about second schedule also, sir? Even here also, W1X is first, R2X is next. So, these two conflict operations are having same order. Like that, I need to verify for each and every pair of conflict operations. Anything else, sir? Let me write this one as W2X. So I have W1X, W2X. This is my second set of conflict operations. Even in this case also, okay, let me write here, sir. Even in this case also, in first schedule, who is first, sir? This is the first fellow, this is the next fellow. In both schedules, he is the first, he is the next. Hope you understood it. So for every pair of conflict operations, the order should not be changed. Okay, there may be so many operations in between those two. We don't mind. But who is coming first, who is coming next? That is the main story. So if there is no difference between the order of the execution and the conflict operations, we will say they are equivalent. Let us do one previous question based on this. Let Ri of Z and Wi of Z denote read and write operations respectively on a data item Z by a transaction Ti. What does it mean, sir? Suppose they given T1 of Y. What it mean is, sorry, it's not T1, right? Suppose they given something like W2 of y. What it means is T2 writing y. That's it. Suppose they given R5 of x. What does it mean, sir? T5 reading x. Of course, we don't have 5 transactions in this example, sir. For explanation purpose, I taken like this. So that is the notation of the operations. Most probably in all the questions they will follow a similar kind of notation. So better to remember it. Right? Now consider the following two schedules. Consider the following two schedules. S1 in which they given some sequence R1 of x, R1 of y, R2 of x, R2 of y, W2 of y, W1 of x. Fine. In S2 R1 of x, R2 of x, R2 of y, W2 of y, R1 of y, W1 of x. Fine. What is the question, sir? Which of the following options is correct? S1 is complete serializable. S2 is not complete serializable. S1 is not complete serializable. S2 is not complete serializable. So mainly they are asking what is complete serializable. Sir, first let me give the clarity. Conflict equivalent schedules. Conflict equivalent schedule means both may be serial or both may be non-serial or whatever it may be. We don't mind. Whatever the schedules, I don't mind. But the order must be same. Sir, what is the order, sir? Order of conflict operations must be same. So that is equivalence. When you are verifying equivalence, they will give both the schedules and we need to verify whether they are equivalent or not. So which is very easy. Just we need to verify whether the order is same or not. But when they ask about conflict serializable schedule, okay, what is conflict serializable? That means they will give only one schedule. This one should be equal to any one of the serial schedules. Any one of the serial schedules. Now the question is, anyone fine. Who is that one, sir? You need to consider each and everything. So that means for the given one, suppose I have only two transactions. First I verify whether the given S is equal to T1 followed by T2. If it is not, then I verify the same S for T2 followed by T1. Unfortunately, if you are having three transactions, I need to verify with all the six. Luckily, if S is equal to the first, no need to do the remaining, sir, because it is already equal to one of the serial schedules. So we can say simply it is complete serializable. Right? Now let us discuss these examples. The first one we are verifying, sir. Schedule S1. Okay. So let me write more clearly. T1, T2. What is the first operation, sir? T1. So it is reading the value of X. Even the second operation also T1. It is reading the value of Y. The third operation is the second transaction. It is reading the value of X. What is the fourth operation? It is reading the value of Y. What about fifth operation, sir? The second transaction is reading the value of Y. What about sixth one? The first transaction is reading the value of X. Now let us consider one serial schedule. Consider one serial schedule. Suppose I want to write all the operations of T1 followed by operations of T2. So that means R1 of X, R1 of Y. I want to complete all the operations of T1, W1 of X. We completed all. Then start this. R2 of X, R2 of Y, W2 of Y. Fine. So we are verifying with this, sir. We don't know whether they may be equivalent or not. If they are equivalent, fine. It is complete serializable. If they are not equivalent, I need to verify the second possible serial schedule also. Now the question is, what are the conflict operations? Conflict operations, when they are read, no issue, sir. W2 of Y, R1 of Y, yes. R1 of Y, W2 of Y. So in schedule S1, let us suppose we are considering this is the schedule S. So is yes. Here in schedule S1, who is first, sir? R1 of Y is first. W2 of Y is next. What about here also? Here also R1 of Y is first. This is next. So there is no problem for this pair. Do you have any other pair, sir? Do you have any other pair? Yes. We have R2 of X, W1 of X. In S1, R2 of X is first, sir. W1 of X is next. But what about here, sir? In S, W1X is first. So the order was changed. Not equivalent. Hope you understood it. So what I need to do, sir? I need to consider another possible serial schedule. What is another possible serial schedule? Since I have only two transactions, let me write the operations of here. R2 of X, second one is R2 of Y, the other one is W2 of Y. Fourth one is, let me write the operations of T1, R1 of Y. Sixth one, W1 of X. Now what about the first set, sir? The first set is R1 of Y, W2 of Y, right? So in S1, he is the first one. He is the next one. In the S, what you are considering? Here, please verify it, sir. R1 of Y, he is the second one, sir. He is the first one. So not equal. So the given schedule is not equal to either T1 followed by T2 or T2 followed by T1. So it is not equal to any one of the serial schedules. So this is not conflict serializable. Hope you understood it. Not conflict serializable. Let me write it. Sir, no need to write the story of like this. Simply you can verify it. R1 of Y, W2 of Y. This is the right. He is first, he is next. Here R1 of Y, W2 of Y. Fine. What about next? R2 of X, W2 of Y. But here it is in reverse order. So they are not equal. Similarly, you can verify it. Now you can verify the second schedule, whether it is equal to any one of the serial schedules or not. I'm sorry, sir. Let us do the second one, sir. Let me write the second schedule S2. This is R1 of X. Then this fellow is reading the value of X. Then the second fellow is reading the value of Y. Then again the third fellow is reading the value of Y. Then the first fellow is reading the value of Y. Then the first fellow is reading the value of X. Right? Then let us consider one serial schedule, sir. You can consider any one of them, sir. Since it's very clear that I need to do first the second one, R2 of X, R2 of Y, W2 of Y. So first I do these operations first. Then I do the operations of T1. R1 of X, R1 of Y, W1 of X. Right, sir? Now the first conflict operation. Where is the first conflict operation? There is a first conflict operation, sir. I hope this is right. R2 of X, W1 of Y. So R2X is first. Here also R2X is first, W1X is next. So this is fine. Let me take one more color, sir, to have more clarity. Let me write it. What is the next conflict operation, sir? W2 R1. W2 first, R1 next. W2 R1. Yes, the same. So this is also no conflict. Okay. Instead of this one, you can write manually also, sir. There is no issue, but the intention is same. So they are same. Okay. Or you can write like this also, sir. Conflict pairs. Follow any one of them, sir. In conflict pairs, what is the first conflict pair? R2 of X, W1 of X. In S1, in S we consider. Here R2X is first, this is next. Here also R2X is first, this is next. So this is no issue. What is the second pair? W2 of Y, R1 of Y. In S1, he is the first fellow, he is the next fellow. Even S also, he is the first fellow, he is the next fellow. So both don't have any issue. They are having same order. They are having same order. Since they are having same order, I can say S2 is equivalent to, who is first, sir? T2 followed by T1. So that's why it is conflict serializable. Hope you understood it. So this is the basic procedure to verify whether the given schedule is conflict serializable or not. But if you do this for 3 transactions or 4 transactions, it may take so much time, sir. So we have a shortcut. For that, we need some small concept from mathematics. Okay. So let us discuss it first. Precedence graph. What is a precedence graph? It is like this, sir. Suppose I have totally some 4 transactions. Then first I will draw a graph with 4 points. Why we have 4 points, sir? Since we have 4 transactions. That's the first point. Suppose I have only 2 transactions. How many nodes we are having in the graph, sir? We have only 2 nodes. Right, fine. Let us assume there is a conflict operation between T1 and T3. Something like T1 is reading the value of X and T3 is writing the value of X. Okay. Or let us write in the notation what we are having. W1X. That means T1 is reading the value of X, and let us assume T3 is reading the value of X. Sir, these two are having conflict. And one more is, who is first, sir? W1X is first. He is the next fellow. So from first fellow to next fellow, I need to draw the line. So from T1 to T3, there should be a directed line. There should be a directed line. Suppose I have one more example. Here I have some T3 is reading the value of Y. Somewhere T2 is writing the value of Y. In this context, this is conflict. Who is the first fellow, sir? T3. Who is the second fellow, sir? T2. So I need to draw a line from T3 to T2. It should be a directed edge. Why directed edge? I need to specify who is first, who is next. Hope you understand it. Like this, for every conflict operation, I need to write the corresponding line. If the line already we have drawn, then no need to draw it. Okay. So for every conflict pair, we need to draw a directed line from the first fellow to the second fellow or the next fellow. Let me take one small example. In T1, let us suppose I have R1X, W1X, and let us assume it is also having RY, WY. Let me have T2, T3 also. Okay. Let me write like this, sir. Now this fellow is reading the value of X, reading the value of Y, and this fellow reading the value of Y, and he is reading Z, writing Z. Then this fellow reading Y, writing Y. Now what is the precedence graph, sir? Take T1, T2, T3. What is the first conflict operation, sir? I think we have, this is the conflict operation. So there should be a line from T1 to T2. Any other conflict? From WX to any other? No, sir. Then from T2 to T3? No, I think. Then from here, please observe it. T3 to T1. So T3 to T1. That's it. This is the precedence graph. Now the question is, why we need this precedence graph, sir? That is the main point we need. Schedule is conflict serializable. Schedule is conflict serializable if its precedence graph don't have any cycles. If its precedence graph don't have any cycles, then we say it is conflict serializable. So let us discuss one of the previous question based on this. Consider this question, sir. So we have three transactions, T1, T2, T3. T1, T2, T3. And they given two schedules. So we need to verify each schedule one by one. Which of the following statement about the schedules is true? Only S1 is conflict serializable. Only S2 is conflict serializable. Both are conflict serializable. Neither is conflict serializable. That means instead of verifying one schedule, we are verifying two schedules. That's it. So the same procedure we need to apply for two times. Let us do it. Consider this. Sir, the first story is T1, T2, T3. Why we written 3 nodes, sir? Because we are having 3 transactions. Now identify the conflict. R1 of X is having conflict with R1 of X is having conflict with anyone? Anyone? No, there is no one. This is also W1 of X, same transaction. When both operations are same transaction, no issue. So R1 of X don't have any conflict. R3 of Y, R3 of Y, R3 of Y. This is W3, no issue. R3 of Y, R3 of Y. There is no issue at all. Okay, sir, how to verify it? Consider this. Okay, it is X. So I need to consider this and this, 182. Then both are read, it's not needed. Then here it is write, but both are 1, it is also not needed. That's it. Then consider second one, R3. Y write, first Y, second Y, that's it. So both are read operations, leave it. Both are third transaction, leave it. So no conflict. Consider the next one, R3 of X. X, S, X. Then please observe it. One is read, one is write, one is 3, one is 1. So it is a conflict. It is a conflict. So who is first, sir? 3 first, 1 next. So I need to draw a line from 3 to 1. Hope you understood this. Then let us consider the next one. R3 of Y. Sorry, R2 of Y, S, Y. Only 1. Yeah, please observe it. Read, write. Second, third. So from 2 to 3, I need to draw a line. Any other? Nothing. Then go for next. R2 of Z. Yes, Z. Oh, we have so many. Now here, same 2, 2. Leave it. Both are read. Leave it. Yeah, please observe it. This is read. This is write. This is 2. This is 1. So 2 first, 1 next. So from 2 to 1, I need to draw a line. Hope you understood it. Then W3 of Y. Y. There is no Y. So no conflict. W2 of Z. Z. Please observe it. W, R, 2, 1. There is a line from 2 to 1. 2 to 1 we have already drawn. Leave it. Then again, same. Right. 2, 1. Draw a line from 2 to 1. It was already drawn. Then Z. Both are 1, 1. No issue. Leave it. The last one, W1 of X, there is no X. So no conflict. For the last one, do you have any conflict, sir? No issue, right? Now, do you have any cycle, sir? No cycle. Am I right? So it is conflict serializable. No cycle, it is conflict serializable. So like that, we need to form the precedence graph and we need to verify whether it is conflict serializable or not. What about next one, sir? I hope you can do it on your own. Let me do it in a quick manner. From R1X, nothing, sir. Sir, please check it. R1X, I have X, X. No issue. Both are read. Both are same transaction. What about second one? R3 of Y. Y. Both are same. Third transaction. R2 of Y, I have only one Y. S. Please observe it. This is read, this is write. This is second, this is third. So there should be a line from 2 to 3. Anything else possible, sir? No. So we completed this one, then go for here. X, S. Conflict. Read, write. 3, 1. So there should be a line from 3 to 1. S. Anything else? No. Z. Both are read. Leave it. S. R. W. 1, 2. 1, 2. Here both are same transaction. So leave it. Sir, you can continue, but before continuing, please observe the graph already got cycle. When graph already got a cycle, it will not be or it cannot be complete serializable. So cannot be conflict serializable. Right? So S1 is conflict serializable, S2 is not conflict serializable. Sir, now the question is, you said this is conflict serializable, right? Now this is equal to T1, T2, T3 or T1, T3, T2. So it is equal to any one of the 6 schedules. Then what is the schedule? In this procedure, we don't have any clue or we don't have any trick to identify the corresponding serial schedule, because when we are saying serializable, compulsorily it should be equal to one of the serial. Who is that one? Here we not identified. Then is there any way to identify with the precedence graph? Yes, we have. For that we need a small concept from algorithms. Topological ordering. Okay, we need this concept from algorithms. Let me discuss or let me give brief introduction about topological ordering. Order of vertices in a directed acyclic graph such that if there is a path from Vi to Vj, something like I have x to y, there is a path or there is a edge. Actually, instead of saying a path, you can say simply edge also, but let me have it. Then Vj should appear after Vi. That may not be immediately, sir. Whenever there is a path from x to y, in my order, I need to have x first, followed by somewhere y next. That may be immediately or that may be somewhere else. But y should not come before x. Okay, let me explain. Now the question is how to write topological ordering. This is my graph, sir. This is one of the topological ordering, sir. Please verify it. Suppose, let me consider any example you can consider, sir. Consider this V4, V3. So there is a path from V4 to V3. So in my order, V4 should come first. V4 should come first, V3 next. Not only that one, sir, you can have anything. Okay. For example, consider V5, V7. So V5 should first, V7 should next. But it should not be like that, V7 here, V5 here. Okay. So whenever there is a directed edge, okay, instead of path, simply easily you can say edge also, sir. No issue. So when there is a directed edge between two vertices x and y, x should come first, y should come next. That is the topological ordering. So we need to have some procedure to find the topological ordering. Okay, let me have that example. First we consider vertex with 0 in degree. What is in degree, sir? What is in degree? Number of incoming lines in simple English. Number of incoming edges. For example, in this case, suppose I consider W2. How many edges they are coming, sir? For V2, only 1. So in degree is 1. What about V4? V4, I think 3 coming. Am I right, sir? Yeah. What about V1, sir? 0. That's it. So every time I need to find a vertex with 0 in degree and I need to write it. Suppose there are 2 vertices with 0 in degree. No issue. You can write any one of them. In this example, who is the in degree, sir? Let me write it first. 0. Here it is 1. Here it is 1. Here it is 2. This is 3. This is 3. This is 2. These are the in degrees. That is the number of incoming lines. Who is the one and only man we are having, sir? V1. So he is the first vertex in my order. V1. Then remove it from the graph. Print V1 and remove it. Okay. So V1 first. Right. Then the orders may change. Because you removed some lines, right? Then again write the orders in degrees. This is 0, this is 1, this is 2, this is 3, this is 1, this is 2. Who is the next hero, sir? V2. So write V2. Print and remove it. Again the degrees will change. What are the degrees? This is 0, this is 2, this is 1, this is 1, this is 3. Who is the hero now? V5. V5. So remove it. Then this is 0, 1, 3, 1. So who is the hero, sir? V4. Remove the hero. Then we have this. Now this is 0, this is 0, this is 2, right? Then who is the hero? We have 2, sir. Either you can write V3 or V7. Suppose I written V3, then I remove it. Instead of this one, I can write V1, V2, V5, V4, V7. Okay, you can write it also. Suppose I written this one, then I will remove it. Whenever I remove it, then who will I get, sir? I will get V7. Then V6. Suppose if I follow that one, here I will get V3, V6. So here we are having 2 orderings. There may be so many number of orderings, sir. Okay, not only one. Sometimes it may be only one. Sometimes we can have more than one ordering also. There is no rule that we need to have only one topological ordering. Why we need this, sir? These orderings will give our serial orders. These topological orders will give our serial orders. Listing concrete serializable. So draw precedence graph. Verify concrete serializable or not. That means cycle or not. If concrete serializable, if conflict serializable, then each topological order is a serial order of transactions. Serial order of transactions which we need. That is, for the serial schedule, my given schedule is equivalent. So this is the way how to list out the serial orders. Then let us do one previous question based on this. Yeah, before going that, I think it is a theory question, sir. Suppose a database schedule S involves transactions T1, T2 and so on Tn. Construct the precedence graph of S with vertices representing transactions and edges representing conflicts. So that is what we are saying precedence graph. The same they said. If S is serializable, then which of the following orderings gives the vertices of the precedence graph is guaranteed to yield a serial schedule? So which orders are? Topological order, right? We don't consider any other order, BFS, DFS and everything, sir. Each topological order will produce a serial schedule to which the given schedule is equivalent. Let us do one example on that. Let Ri of Z and Wi of Z. Sir, the same notations, Ri of Z. So the meaning is Ti is reading Z. That's it. So consider the schedule with 4 transactions. Fine. Which one of the following is serial schedule is conflict equivalent? Right? So we need to form the graph and we need to identify it. So T1, okay, let me write it here, sir. I think we need to some space. Right, fine. Now with R4 of X, any schedule, yes, conflict here, sir. All the remaining are read only. So 4, 2. Fine. Then what about second, sir? X. These are read operations. These are same. So leave it. Then R3 of X only again. Again I have X. 3, 2. They are conflict and having. So 3, 2. Fine. Then R1 of Y. This is no issue, same, sir. Let's come here. Yeah, 1, 3. 1, 3. Then 1, 4. Can I have? No, both are read. So we can leave it. W1 of Y. 1, 2, 3. 1, 2, 4. Both are conflict. 1, 2, 3. We drawn. 1, 2, 4. Yes. X. We don't have any X. Leave it. Y. Yes, I have Y. 3 to 4. 3 to 4. S. Fine. Now, is there any cycle, sir? The first question. Sir, if there is a cycle, there is no concept of conflict serializability. There is no topological order, anything. Nothing is. So, I think here we don't have any cycle. Please check it, sir. Yeah, we don't have any cycle, sir. So, that is the first point. Conflict serializable. Okay. Now, let me write the graph. So, for that, let us consider the graph T1, T2, T3, T4. Right? Let us write the topological ordering. What are the integers? This is 0. This is 2. This is 2. This is 1. So who is our hero, sir? T1. So our first answer is T1. Right? Then remove it. If I remove T1, what the graph I have, sir? T2, T4, T3. What are the lines? T4 to T2, this is and this is. Now what are the in degrees in this, sir? I think this is 2, this is 0, this is 1. Who is the hero? T3. So remove the hero. If I remove the hero, then I have only T4, T2. T4, T2. Am I right, sir? So the one and only line is this one. What are the in degrees? This is 1, this is 0. Who is the hero, sir? T4. Of course, we done 3. You can have T2. T1, T3, T4, T2. 1, 3, 4, 2. 1, 3, 4, 2. Yes. Hope you understood it. So this is the easiest way to verify whether it is concrete serializable or not. Okay. We have number of questions on serializability, sir. Because of the time constraint, we are discussing only one question for each model. Okay. You can practice the remaining questions based on this concept. View serializability. What is view serializability? It is like this, sir. Suppose I have two transactions. It's not two, sir. Let me have like this. Let us assume I have totally some 10 transactions. Okay. What I need to do is for each data item, we need to verify 3 conditions. So that is for each data item, not for only one item. So we need to verify 3 conditions. So what are the 3 conditions? The first condition. Suppose this is my schedule 1, this is my schedule 2. Okay. Let us assume some T4 is reading the value of X. Some T4 is reading the value of X. Okay. Before T4 reads it, no one modifies. That means T1 reads initial value of X. T4 reads initial value of X. In schedule 2 also, compulsorily T4 need to read initial X. That may be at the end, that may be at the beginning, but compulsorily it need to work with initial value. So when T4 is working with initial value of X in S1, compulsorily in S2 also it need to work with initial value. That may be at morning, that may be at afternoon, that may be at evening. We don't mind. What is condition 2? The question is, who retain the final value of X? Who retain the final value of X in S1? Suppose T8 retain the final value of X. Then in S2 also T8 should write the final value. That means after T8 writes the value of X, no one should change it. No one should change it. So these two are very clear, sir. Suppose if transaction 5 is working with initial value, it should work with initial value in both schedules. Suppose transaction 5 is writing the final value, it need to write the final value in both schedules. Okay. Now the third condition. T4 is working, sir. T4 is working, but it is not initial value. But it is not initial value. Sir, whenever it is not initial value, what does it mean? Someone modified it. Who is that someone, sir? Suppose T4 is working a value which was modified by T7. That means T7 modifies X. In between these lines, there may be some other operations, but no one modifies it. That means T1 is working with T7 value. T4 is working with T7 value. T4 is working with T7X. Am I right? That means the value of X which T7 produces. In schedule 2 also the same should happen. T4 should work with a value of X. It should be modified by T7. In between these two, suppose some T8 modified the value of X, then T4 should not work with it. Okay? Because for T4, who is the supplier? T7. So here also we have T7. Okay? When coming to view serializability, it maybe seems to be some flimsy, sir, to understand, but please understand it. Three possibilities. What is the initial value? Who is the final write? These two are very clear, sir. Transaction reading initial value. It should happen in both. Final write. Suppose T10 is writing final write. It should happen in both. Modified value. Then modifies. For T4, who is supplier, sir? The same supplier should supply in both. Right? So let me give one example to have more clarity on this. Sir, first operation, second operation, third one, fourth one. Now the first condition, initial value. Sir, T1 is reading. T1 is reading initial. In schedule 1, assume this is schedule 1, this is schedule 2. In both schedules, T1 is doing only initial read. What about T2, sir? T2 also reading, sir, but it is not initial. It is modified, right? If it is modified, who is the supplier for T2, sir? He is T3. Here also, who is the supplier for this one, sir? T3. Hope you understood it. Whether it is initial value, fine. If it is a modified value, who is the supplier? Then any other reads? No. What about writes? T3 writing. T3 writing X. That is the final write. Is it final write in both? Yes. The last one. T3 writing Y. After T3 writes it, no one writes it. So it is the final write in both. Hope you understood it. So these are the three conditions we need to verify for view serializability. Hope you understood it, right? So let us do one question on this, sir. Consider the following schedules S1, S2 of the transactions T1, T2, T3. We have three, fine. Okay. And it is a MSQ, sir. Please observe it. Schedule S1, S2 are view equivalent. Schedule S2, S4 are equivalent. So which of them are equivalent, right? So coming to the first two, let us verify the first one, S1, S2. So this one you are verifying, sir. Okay. First read. Let us consider one by one, I think. S1. Okay. Let me write like this. S1. Sir, we have the first one, read. T3 reads X. Is it modified? Yes. It is modified. When it is modified, who is the supplier, sir? T2 in S1. Then what about here, sir? It is modified. T2 reads. Yes, it is modified. First of all, we need to verify modified or not. Both let us do it, sir. modified. Who is the supplier? In S1, the supplier is T2. In S2, the supplier is T1. Please verify it, sir. Okay. He is reading the value who is supplied by this volume. He is reading a value who is supplied by T1. So these two are not equivalent. So this is not correct. Okay. Then they given about S3, S4. S3, S4. Okay, in S3, S4, who is reading R1? So T1 reads X. Is it modified? No, sir. It is initial value. Any other reads? No. Then T2 writing. T2 write. Is it final? In S3, is it final, sir? No. In S2, it is final. So they are also not conflict equivalent. So S3, S4 also not equivalent. Hope you understood it. Right, sir? So this is the story about view equivalence and conflict serializability and serializable schedules. So in next class, we will see the concurrency control protocols like locking protocols and timestamp based protocols. Thank you.